This is a review for your fall semester final. This review is going to be broken into a couple of parts. On our first part, we're just matching. So matching the interval or set of numbers below with its correct notation. So these first matching goes with answers 1 through, with questions 1 through 3. So on our first one, we have from -3 to 1. -3, it has an open dot, so we're going to use a parentheses to 1 with a close. That is C. Number 2, those are all the numbers less than -1, so an interval notation that'd be from -infinity to -1. That isn't one of our options up here, so we're going to need to change, or greater than 5, so from 5 to infinity. That isn't one of these, so we need to change this to set notation or set builder notation. So the set of x's such that x can be less than -1 or x is greater than 5. That matches up with D. E, the set of whole numbers greater than or equal to 13. So x is a whole number. That's shown with that W, and x is greater than or equal to -13. So that is going to be B. Our next answer choices, these graphs, go with questions 4 and 5. So our first one is x squared minus 16. I know this is a parent function that's just been shifted down 16, and that is going to be B. Number 5 is a little bit trickier. You're going to want to type that into a graphing calculator. So you've got y equals, you're going to clear out whatever's in there, and you're going to type in 1/2 x squared minus 7x plus 20. And I'm going to go to Zoom 6. It's just a standard window. I may need to zoom out a little bit. I can see that one's been moved over to the right. The only ones of these that have been moved to the right is A. So that's going to match up with A. If you wanted to see more of your graph, remember you can zoom out a little bit to be able to see more of that graph. Match the nonlinear system or quadratic equation below with its solution. So these answer choices are going to go with these next 4 questions, and I want to find out where these intersect. Okay, that's the goal of a system, is to find the points of intersection. So of these, the first 3 are all systems. It's all 2 different equations and where they intersect. The last one is the quadratic equation. So for those systems, I'm going to go to y equals, clear this out, type in x squared minus x minus 6 and 2x minus 2, trace it. So I want to find these 2 points of intersection. So second calc, number 5. So I have 1 at -1, -4. And 1 at 4, 6. So that is going to be answer choice F. Number 7, I have x plus 2 squared and -x squared minus 4x minus 2. This one is also going to have 2 intersection points. So second calc, intersection. This one is at -1, 1. And -3, 1. So that is A. So again, I'm going second calc. No, I'm going a little fast. Choose a number 5, and then I hit enter 3 times. My last one, now this is an x equals. You can't type x equals equations in your calculator right now, so I just need to know that that is a vertical line at 6. Alright, I am going to go ahead and solve this for y. So to solve this for y, I'm going to move y over here, negative 13 over here. So when I do that, I'll have a positive y is equal to negative x squared plus 8x plus 13. So I'm going to type that into y equals. Okay, and again, I'm looking at a positive or a vertical line at 6. Okay, so I may gonna go my y max 20. So if I drew a vertical line at 6, I'd want to see where that intersected. And I can do that by just typing in 6. If I press trace, I can type in any value for x, hit enter, and it tells me that y value. And that y value there is at 25. So 625 would be where they would intersect. On number 9, I'm going to put the left side in y1 and the right side in y2. So y equals negative x plus 5 and x plus 10 minus 35, and then in y2 I'm putting in the right side of this. So x plus 5, x plus 2 plus 25, and I want to see where these intersect. And because this is an equation, I'm only looking for the x values. Make sure I typed it in correctly. Zoom out. Alright, and it looks like they might touch right there. I'm going to zoom into that spot right there. And they don't. They have a little gap right there, so that's going to have no solutions. Those won't cross, so that is H. Our next section says graph the function and its parent function, then describe the transformations. I'm going to go ahead and describe the transformation. Here you've got a tube out front, so that's going to be a vertical stretch of 2. If you wanted to graph it, go to y equals. Type in x squared, that's our parent function, and then 2x squared. Going to go to zoom 6, and you can graph it from here and using your table. Go back to y equals number 11. This is going to have a vertical stretch of 3. It's going to move left 2 and up 2. So to get an absolute value in your calculator, you're going to go to math, over to number, and it's that first choice, x, that's our parent function, and then 3, math, over to number, absolute value of x plus 2 plus 2. There's our parent function, there's our transformation. Number 12, write a function g whose graph represents the indicated transformation of the graph of the function. So, shifts 6 units down. So I'm going to subtract 6 from this. So g of x is equal to negative 2x. 4 minus 6 is a negative 2. 13 has a vertical shrink by a factor of 1/5. So I'm going to multiply everything by 1/5. So g of x is equal to 1/5 times the absolute value of x plus, and 10 times 1/5, or 10 divided by 5, is 2. Number 14. Alright, so here they give me f of x is equal to x, and I want to find the equation of g of x. Okay, so g of x has a y-intercept right here at -1, and a slope of it goes up 1 and over 2. So it has g of x is equal to 1/2, that's our slope, x plus our y-intercept -1. That is y equals mx plus b. Number 15 says solve the equation, graph the solutions if possible. I'm going to start solving these up here. So 15, I'm going to start solving right here. Now it's absolute value, so I know that 2z could be equal to 8, or the opposite of 2z could be equal to 8. I'm going to solve both of those. So 2z is equal to 8 when z is 4. Negative 2z is equal to 8 when z is -4. So my solution can be -4 or 4. Number 16. So I'm going to go ahead and subtract 8 from both sides. So that gives me absolute value of z minus 2 is equal to 9 minus 8 is 1. Then I'm going to split it. So z minus 2 can be equal to 1, or the opposite of z minus 2 can be equal to 1. Add 2 to both sides, z is equal to 3, or distribute negative z plus 2 equals 1, subtract 2, negative z is equal to -1, divide by negative, z can be +1. So those are my two solutions for number 16. Number 17. So again, I'm going to split it. 2x plus 2 is less than or equal to 4, or the opposite of 2x plus 2 is less than or equal to 4. Subtract 2. 2x is less than or equal to 2. Divide by 2. X is less than or equal to 1. Distribute. Negative 2x minus 2 is less than or equal to 4. Add 2 to both sides. Negative 2x is less than or equal to 6. Divide by negative 2. X is greater than or equal to -3. Now it also told me to graph this one, so I'm going to draw my number line. Now these are both going to be solid dots because I've got the equal to. And my numbers that are less than 1 are on its left. My numbers greater than -3 are on its right, so it's this inside section. Number 18. So x plus 3 is greater than or equal to 2, and the opposite of x plus 3 is greater than or equal to 2. Subtract 3 from both sides, so x is greater than or equal to -1. Distribute, negative x minus 3 is greater than or equal to 2. Add 3 to both sides, negative x is greater than or equal to 5, and divide by -1, so x is less than or equal to -5. So -5 and -1 are my points that I'm going to plot. And I'm looking for where x is greater than 1 or x is less than -5. Number 19. So 3x plus 6, absolute value of 3x plus 6 is greater than or equal to -6. So I'm looking where 3x plus 6 is greater than or equal to -6, and where the opposite of 3x plus 6 is greater than or equal to -6. Subtract 6. 3x is greater than or equal to -12. Divide by 3. X is greater than or equal to -4. Distribute. -3x minus 6 is greater than or equal to -6. Add 6 to both sides. -3x is greater than or equal to 0. Divide by -3, and x is less than or equal to 0. So 0 and -4. X is less than 0 and greater than -4. Number 20. You're building a rock wall for a flower bed along your 42-foot long driveway. You want the wall to be 1/2 the length of your driveway, with the absolute deviation of at most 6 feet. So that means that it can be 6 feet greater than or 6 feet less than. Write and solve an absolute value inequality that represents the possible lengths for your wall. So 21 feet, that is half of your 42. So x minus 40 minus 21, and it can be at most, so less than or equal to 6. So if I want to solve this to make sure that I've written it correctly, I would have x minus 21 can be less than or equal to 6, or the opposite of x minus 21 is less than or equal to 6. Add 21. So I know my driveway has to be less than 27 feet. Distribute, negative x plus 21 is less than or equal to 6. Subtract 21, so negative x is less than or equal to negative 15. Divide by negative, x is greater than or equal to 15. So I know that it has to be between 15 and 27 feet. Number 21, write it in interval notation, the real numbers from -4 through -1. Now that doesn't say and, so I'm just going to use parentheses, -4 through -1. Number 22, solve the system. So to solve the system, I've got 3 equations with 3 variables. The easiest thing to do is to put this in a matrix. So when I put these in a matrix, I want them in standard form, which means I have my x's, my y's, my z, and then I have it equal to a constant. My first equation, 2, 3, -8, and 10. My next equation, 1, -4, there's no z value, and 1. And my last equation, -2, -3, 8, and 5. So I'm going to second matrix, over to edit, and this is a 3-row by 4-column. Then I type in my elements. Once I get that typed in, I want to go to second quit. I'm going to go back to second matrix, over to math, and down to RREF. Then go back to second matrix, choose matrix A, and then I want to look at this solution. So normally I'm looking at this last column, but I can see there's something interesting going on right here. So I'll look at this last row. If this last row is all zeros, that's going to be an infinite number of solutions, but it's all zeros but a 1 right there. That's going to be when it has no solution. So these 3 lines will not intersect. So there's no solution on number 22. Number 23, I'm going to solve it the same method. So my matrix, -1, -5, +1, 17. -5, -5, +5, +5, 2, 5, -3, and -10. Second quit, back to matrix, RREF. Alright, and this one is going to have, you can see this last row 0, 0, 1, and then it's got a number right here. So this is the ordered triplet. So your x value, then your y value, then your z value. So the solution here is -1, -4, -4. That's going to be where those intersect. Number 24. The school government consists of 7 to 10 representatives from the junior and senior classes. There must be at least 2 juniors and at least 4 seniors in the school government. Write a system of inequalities that represents this situation. Let x be the number of juniors and y be the number of seniors. Alright, so they have to have at least they have to have between 7 and 10. So 7 is the smallest. Can be equal to it of x plus y, which has to be less than or equal to 10. and there has to be at least 2 juniors. So x has to be greater than or equal to 2, and at least 4 seniors. So y has to be greater than or equal to 4. That is your system. Number 25. You want to write an augmented matrix. So again, we want to get our x, y's, and z's all on one side. So I'm going to move the 12z over. And I'm putting x, y, and z, and then my constant. So I have no x's, so 0. My y is negative 17. My z is going to be a negative 12 because I'm moving it to the other side. My c is going to be a negative 7. This next one, I'm moving the y over. My x is negative 13. I'll have positive 1y, have no z's, and I have negative 20 for my constant. And on my last one, I'm moving my 12y over. So I have negative 14 x's, 12 y's, 5 z's, and my constant is 2. That is the first section of your review. I'll complete the rest on our next video.